Welcome back to The Explainer. So today, we're diving into a quiet but honestly absolute revolution that is happening literally right under our feet, out in our fields, and deep inside our cities. We're talking about the convergence of artificial intelligence, advanced sensor networks, and environmental science, and how this trio is actively solving some of the most severe global resource crises of our time. It's just a fascinating look at how our world is practically learning to sense, think, and adapt in real time.
Let's kick this off with a number that kind of stops you in your tracks. 70%. That is the exact chunk of global freshwater use that currently goes straight into agriculture. Just think about that. Water is literally the lifeblood of our civilization. But the traditional ways we farm are, well, they're incredibly inefficient. It leads to massive overuse and huge environmental stress. So this single statistic completely hits the nail on the head as to why we desperately need technological intervention. We absolutely cannot sustain this without fundamentally changing how we manage our resources.
Okay, so how do we actually fix this? Here is our roadmap for today's explainer. Section 1, the world learns to sense. Section 2, AI in the fields. Section 3, greening the concrete jungle. Section 4, sensor integration hurdles. And finally, Section 5, the future of sensing.
All right, let's jump right into Section 1, the world learns to sense, where we'll establish the actual technological foundation of this whole revolution.
So, drawing from Fatima Jahey's 2025 master's thesis out of the University of Jyväskylä, we get a clear picture that advanced sensor systems and the Internet of Things, the IoT, are just completely evolving. We aren't dealing with your old dumb thermometers or simple mechanical tripwires anymore. These are networks of everyday devices that are processing data right there at the source. We're talking about a massive shift from basic detection to what is essentially an intelligent, highly responsive central nervous system for modern society.
Now, you might think academia is just stuck in the lab, right? But take a look at the massive blue chunk in this breakdown of 150 recent academic papers analyzed in Che's thesis. Nearly 47% of the research is focused entirely on real-world applications. That visually proves that the scientific community isn't just theorizing here. They are overwhelmingly focused on actual, boots-on-the-ground implementation. Researchers want these sensors out in the dirt, swimming in the water, and wired into our cities to solve real problems today.
And that perfectly tees up Section 2, AI in the fields, where we see exactly how this tech is stepping up to solve the global water crisis. Let's just pit traditional farming directly against smart farming for a second. With traditional farming, you're usually relying on fixed schedules and manual monitoring. Honestly, it's essentially a lot of guessing, which naturally leads to huge water waste. Like, if it rains, the sprinklers might still be running. But then you look at smart farming, and it completely changes the game. AI algorithms are constantly digesting live weather forecasts, real-time soil moisture levels, and even data beaming down from overhead drone sensors. The result? Tailored, ultra-precise watering. We're talking about a plant getting exactly what it needs, down to the actual drop at the exact right moment.
The real takeaway here is the concrete, undeniable impact this is making across the globe right now. Just look at some of these massive wins. Out in California, vineyards are seeing a solid 25% reduction in water use. Over in India, rice farmers are leveraging this tailored water management to bump their yields up by 30%. In Israel, AI-driven drip irrigation on tomato farms is cutting evaporation by 35%. Down in Brazil, their huge sugarcane fields are using drone sensors to slash water usage by 40%. And honestly, my absolute favorite, smallholder farmers in Kenya using affordable IoT apps are seeing a staggering 50% increase in their maize yields. So this isn't just about saving water, it's literally about growing more food with way fewer resources. It's incredible.
And, the market is completely catching on. By the year 2026, the smart irrigation market is projected to hit a mind-blowing $3.7 billion. That massive number alone proves that transitioning to sensor-driven, AI-powered agriculture isn't some niche, experimental thing anymore. It is a booming, globally recognized economic necessity.
Okay, moving away from rural landscapes and right into our dense cities, we hit Section 3. Greening the concrete jungle. This is all about sustainable urban water reuse.
Let's zoom in on a fascinating, super specific micro-application over in the Middle East, which comes from some brilliant applied research at Hamad bin Khalifa University. So, Qatar relies heavily on incredibly energy-intensive desalination to get its fresh water. To combat that energy drain, they've engineered the Qatar Grey Water Project. Step 1, they collect lightly polluted indoor gray water.
So think of the water running down your bathroom sink. Step 2, they run that water straight through living, vegetated walls and biochar media that are built directly into the building. Step 3, that naturally filtered water is instantly reused for things like landscaping and flushing toilets.
But you might be wondering, how do they actually filter it without relying on massive, clunky industrial plants? Well, it's through this ingenious, nature-based engineering. They use low-cost biomass, specifically biochar made from everyday leftover coffee waste, alongside super-resilient ornamental plants like Rewire tuberosa. This whole process is called phytoremediation. The plants and the coffee waste act as literal biological sensors and functional filters, just naturally pulling contaminants right out of the water. It's a gorgeous integration of natural biology and modern urban infrastructure.
But of course, that brings us to Section 4, Sensor Integration Hurdles. Or, put simply, why on earth isn't this everywhere yet? It's the most natural question to ask, isn't it? If we can literally cut water use by 50% on farms and filter urban water using coffee grounds and plants, why isn't every single farm and building in the world already wired up with this? Well, as it turns out, bridging that gap between a highly successful pilot project and a massive global rollout is incredibly complex.
When we synthesize all the constraints from both the agricultural data and the academic thesis, we get this really multidimensional picture of the barriers. Technically speaking, we're dealing with severe power efficiency and battery constraints. I mean, you can't exactly run around constantly replacing batteries on thousands of little sensors spread across a 500-acre farm. Then there's the issue of data reliability and mechanical noise. From a systemic level, upfront deployment costs can be super steep. And the second you connect a farm or a city water grid to the internet, you fling the door wide open to IoT security threats and cyber attacks. Then, of course, there are the ethical considerations. When an AI is making the calls on how vital resources are allocated, we have to guarantee there's no baked-in bias. And let's be real, there are totally valid privacy concerns when you start pervasively monitoring public and private environments.
But overcoming these hurdles is exactly what top researchers are actively attacking right now. If you look at Chahay's systematic review, notice how aggressively the initial data is funneled down. Out of 150 unique records they initially screened, only 40 full-text articles met the absolute strictest scientific quality criteria for addressing these specific integration challenges. The scientific community is heavily scrutinizing these bottlenecks, simply because solving them is the only way this technology is ever going to scale.
And that brings us to our final act, Section 5, the future of sensing, and exactly how we are going to overcome those bottlenecks.
Researchers are cooking up some genuinely breathtaking novel architectures to eliminate these constraints. We're seeing the rise of machine learning sensors, where the AI isn't in some distant cloud, but physically embedded right into the tiny hardware itself. That goes hand in hand with in-sensor computing, processing the data right there at the source, which virtually eliminates latency. And to solve that annoying battery issue, we're pioneering battery-free IoT platforms that literally harvest ambient energy, stuff like ambient light or basic motion, straight from their environment so they can power themselves indefinitely. Finally, we are heavily utilizing digital twins. This means creating living, breathing digital copies of entire farms or city water systems so that we can simulate and perfect operations before we deploy a single real drop of water. It's like a giant puzzle coming together.
As we wrap up this explainer today, I want to leave you with this powerful thought synthesized directly from our sources. Progress and challenges are deeply intertwined. The modern world is learning to sense, but we must ensure it senses sustainably and ethically. Technology has given us the unbelievable tools to solve our most critical resource crises, to grow way more, to waste a lot less, and to build significantly smarter environments. But at the end of the day, it's on us to deploy this central nervous system in a way that's secure and fair. So as we race to wire the Earth with a digital nervous system, we really have to ask ourselves, once the entire planet is sensing and thinking, who will ultimately be in control of the switch?